Imagine you have a billion vectors and a single query, and you need the closest matches right now. Checking every vector one by one is exact, but at that scale it's hopelessly slow. Faiss is the library that solves this. Built by researchers at Meta and released as open source, it has become the most widely used tool for fast similarity search and clustering of dense vectors, and it quietly powers similarity search inside many of the vector databases you already use every day. Let's unpack how it pulls that off. Here's the tension Faiss was built around. You want the true nearest neighbors, but you can't afford to look at everything. The obvious method compares your query against every single vector in the database. It's perfectly exact, and for a few thousand items it's totally fine. But once you're at millions or billions, that full scan becomes far too slow to serve in real time. Faiss takes a different bet. Instead of exact search, it offers approximate indexes that give you almost the same neighbors for a tiny fraction of the work. You trade a little accuracy for enormous gains in speed and memory, and you get to choose exactly where that line sits. So how do you actually use it? The workflow is the same 4 steps no matter which index you choose. First, you pick an index type, and this is really the key design decision. Maybe a flat index for exact search on small data, or an inverted file index that only looks at nearby clusters, or a quantized one that compresses vectors so billions fit in memory. Each choice trades speed, memory, and accuracy differently, and part of the skill is knowing which one fits your workload. Then you train the index on a sample of your vectors. This is where Faiss learns the structure of your data, the cluster centers, and the compression codebooks, so it knows how to organize everything before a single real vector goes in. After training, you add your actual database vectors. Faiss slots each one into the structure it just learned, assigning it to clusters and encoding it compactly. Now the index is populated and ready to answer questions. Finally, you query. You hand Faiss a vector and ask for the top nearest matches, and it returns them fast. Push that same query onto a graphics card and it runs dramatically faster still, which is one of the library's biggest advantages. Now, why has Faiss become the default engine so many teams reach for? 3 qualities really carry it. First, it's a whole toolbox of indexes rather than one algorithm. Inverted files for skipping clusters, product quantization for compression, graph-based search for accuracy. You match the index to your data instead of forcing one approach onto every problem. Second, those indexes compose. You can stack an inverted file with product quantization so you get both cluster skipping and compression at once, and the whole thing accelerates on a graphics card. That combination is how billions of vectors fit and stay fast. Third, it's the quiet backbone under the ecosystem. When a vector database advertises fast similarity search, Faiss is very often the engine doing the heavy lifting underneath. Learning it means understanding what those higher-level tools are actually running. Alright, let's pull the essentials together. Faiss is Meta's open library for fast similarity search over dense vectors, and it sits inside many vector databases. Because exact search doesn't scale, it gives you approximate indexes that trade a little accuracy for big wins in speed and memory. You pick an index, train it, add your vectors, then query for the nearest matches, optionally accelerated on a graphics card. Inverted files, product quantization, and graph indexes all compose together, which is what makes billion-scale search practical. Want more machine learning ideas explained this clearly? Head over to standarity.com and keep exploring.